Hello everyone, myself Mrs. Namita Amrutkar, working as an assistant professor in Abida Inamdar Senior College. I am excited to take you through the fundamental of data structure and algorithm and their importance in computer science. Let's start it by defining what data structure are. In simple terms, a data structure is a way of organizing and storing data so that it can be accessed and modified efficiently. A data structure is not only used for organizing data, but it also used for processing, retrieving and storing data. Data structure algorithm is about finding efficient way to store and retrieve data, to perform operation on data and to solve specific problem. DSA can decide which data structure or algorithm is best for given situation, understand how to approach complex problem and solve them in systematic way. Why there is a need of a data structure? Now we can say that data structure and algorithm are used in virtual every software system, from operating system to web application. It is used for managing large amount of data such as in social network or a search engine, for scheduling tasks to decide which tasks a computer should do first, for planning routes like in GPS system to find the shortest path from A to B, for optimizing process such as arranging tasks so they can complete as quickly as possible, for solving complex problems, for finding the best way to pack a truck, to making a computer learn from data. Now we have to learn about some basic terms. First one is what is my data? Data is nothing but a raw, unorganized, unprocessed information. For example, information collected for writing a research paper is a data until it is present in an organized manner. Second term is information. Information is the process, organized data, and that is beneficial in providing useful knowledge. For example, the data compiled in an organized way in a research paper provides information about particular concept or topic. Data object. Data type defines the type of value stored in a variable. This decides the type of operation performed and function called on this value, whereas a data structure is a collection of similar or different type of data which is used to organize and manipulate data in a program. Next concept we have to learn about data object. A data object is a structure for describing data entity by grouping a set of related fields. For example, a supermarket online order application might contain a customer data object. The customer data object includes the fields that describe the supermarket's customer such as first name, last name, full name, email address and phone number and so on. Abstract data type. There might be a situation when we need an operation for our user defined data type which have to be defined. This operation can be defined only as and when we require them. So, in order to simplify the process of solving problem, we can create data structure along with their operation. And such a data structure that not built in are known as abstract data type. We can say that abstract data type is a programming concept that defines high-level view of a data structure without specifying the implementation detail. In other words, it is a blueprint for creating a data structure that defines the behavior and interface of the structure without specifying how it is implemented. Data structure can be broadly categorized into linear and non-linear data types. Linear data structure, a data structure in which data elements are arranged sequentially or linearly, where each element is attached to the previous and next adjacent element, is called a linear data structure. Non-linear data structure, a data structure where data elements are not placed sequentially or linearly, are called non-linear data structure. In a non-linear data structure, we cannot traverse all the elements in a single run go. For example, tree and graph. Linear data structure categorized into static data structure and dynamic data structure. Static data structure has a fixed memory size. It is easier to access the element in a static data structure. The example of static data structure is array. Dynamic data structure. In a dynamic data structure, the size is not fixed. It can be randomly updated during the runtime. Example of dynamic data structure is queue stack. Now we learn algorithm analysis. Countless times we have heard our math teacher specify different methods for solving a particular problem. The goal is to use short and easy technique instead of lengthy, complicated ones. Likewise, while writing a code, it is a good practice to use minimum resource for execution. Here, resource indicates the time and memory requirement of an algorithm. Imagine you select something on Google and it took more than an hour to display the result. Would you ever use Google search again? Probably not. Hence, the time complexity and space complexity are essential factors in determining whether or not the algorithm is good. Algorithm analysis is the process of determining the efficiency of an algorithm in terms of the time and space it requires. The algorithm can be analyzed in two levels: prior analysis and posterior analysis. Prior analysis is the theoretical analysis of an algorithm which is done before the implementation of an algorithm. Various factors can be considered before the implementing the algorithm, like processor speed, which has no effect on the implementation part. Here, the posterior analysis is a practical analysis of an algorithm. The posterior analysis is achieved after implementing the algorithm using any programming language. This analysis basically evaluates that how much running time and space taken by the algorithm. Now we have to learn about space and time complexity. The performance of the algorithm can be measured in two factors: space complexity and time complexity. Time complexity of an algorithm is the amount of time required to complete the execution. The time complexity of an algorithm is denoted by the big O notation. The time complexity is mainly calculated by counting the number of steps to finish the execution. Space complexity. An algorithm space complexity is the amount of space required to solve the problem and produce an output. Similar to the time complexity, space complexity is also expressed in big O notation. For an algorithm, the space complexity is required for the reason to solve program instruction, constant and variable values, to store, to track the function call, jumping statement, etc. Let's explore its different types. Algorithm analysis. Types of algorithm analysis are base case, worst case, average case. Base case defines the input for which the algorithm takes less time or minimum time. In the base case, calculate the lower bound of an algorithm. For example, in a linear search, when we search a data is present at the first location of large data, then the base case occurs. Worst case, define the input for which algorithm takes a long time or maximum time. In the worst, calculate the upper bound of an algorithm. For example, in the linear search, when we search the data is not present at all, then the worst case occurs. Average case. In the average case, take all random input and calculate the time for all inputs, and then we divide it by the total number of input. Now we have to learn about asymptotic notation. These are big O notation, omega notation, theta notation. Big O notation that measure the performance of an algorithm by simply providing the order of growth of the function. This notation provides an upper bound on a function which ensure that the function never grows faster than the upper bound. So it gives the least upper bound on a function so that the function never grows faster than this upper bound. It is the formal way to express the upper boundary of an algorithm running time. It measures the worst case time complexity or the algorithm's longest amount of time to complete its operation. Second one, omega notation. It is basically describe the base case scenario which is opposite to the big O notation. It is the formal way to represent the lower bound of an algorithm's running time. It measures the best amount of time of an algorithm can possibly take to complete or best case time. It determines what the fastest time that algorithm can run is. If required that an algorithm take at least certain amount of time without using an upper bound, we use big omega notation. Theta notation. The theta notation mainly describes the average case scenario. It represents the realistic time complexity of an algorithm every time an algorithm does not perform worst or best in real world. Algorithm mainly fluctuate between the worst case and the best case, and this gives the average case of an algorithm. Big theta notation is mainly used when the value of a worst case and the base case is same. It is the formal way to express both the upper bound and lower bound of an algorithm running time. Now we'll learn how to calculate complexity by exploring some example. Imagine a classroom of 100 students in which you gave your pen to one person. You had to find that pen without knowing to whom you gave it. Find time complexity of the above problem. You go and ask the first person in the class if he has the pen. Same question is asked for the second one, third one, and so on. So you ask this question to 100 students. So time complexity order of 100. If n student, then yes, it is order of n. In the above code, hello world is printed only once on the screen. So the time complexity is order of 1 and auxiliary space is order of 1. Right? Before we conclude, let's quickly summarize the key point we have to cover today. We have started with the definition of data structure and understood their importance in organizing and managing data efficiently. We explore various types of data structure including linear and non-linear types, algorithm analysis and its type. Also learn how to calculate the time complexity and space. Thank you all for your attention and participation. I hope you found this session informative and useful.